Welcome to MS 100 lessons, and in this lesson we'll be focusing on physical sciences, paper 1, mechanics, and the focus is on objects. So this is just the basics of mechanics that every learner needs to understand, and it comes with a lot of details in terms of explaining how objects work in physical sciences. So the outcome for this lesson is that you should be able to know the forces or the different forces that act on an object. It's either the object is stationary and not moving, you have to understand the forces that are acting on that object, or maybe that object is moving, then you still need to understand the forces that are acting on that object, because the forces affect the motion or the nature of the objects, right? And then number 2, the outcome that you have to know is how you identify the forces if you're given a certain scenario. And then the last objective of this lesson is you learn how to visualize all those forces so that it gives you a clear picture of the forces that are acting on the object, right? So let us use an example to explain this topic. So let's say we have an object. Okay, so we have an object which is a box or a brick or it can be any object. Okay, so for grade 11 and grade 12, there are actually 5 possible forces that can act on that object. So force number 1 that can act on an object or on that object is your gravitational force. So your gravitational force is your weight of the object. Okay, so now remember, the outcome for this lesson is for you to actually identify the forces and be able to visualize the forces, right? So now, how do you know that there is gravitational force on a certain object? So that comes with identifying your forces. How do you know that we do have gravitational force? So the most important thing is the wording of the statements in physical sciences. So for example, if they mention that you have an object of mass 5 kg, for example, then that 5 kg, provided that it's on Earth, that 5 kg is an indication that you have your gravitational force, which is your weight. Okay, so the way you identify whether gravitational force is present is if you're given the mass of that object. For example, in this object, if they say an object of mass 5 kg, then you should know that there is mass, meaning that we should have gravitational force, right? So now, how do we actually calculate that gravitational force of that object? So in terms of a formula, it's your gravitational force, which is equal to your mass that we are given. In this case, your mass is 5 kg, multiplied by your gravitational acceleration. So your gravitational acceleration, which is a constant, and that is 9.8 meters per second squared. So this is how you quantify your gravitational force. This is your formula for calculating your gravitational force. So in terms of interpreting physics statements in grade 11 and grade 12, you have to read the statement. The moment it says an object of 5 kg or an object of mass 5 kg, then you should understand that we do have what we call gravitational force because of that mass. That's number 1. And number 2, you should be able to understand that you can actually calculate that gravitational force using the formula Fg is equals to mg. Okay, so now we have understood how we can calculate that gravitational force. Now let us look at the direction, because the force is a vector, it has both magnitude and direction. So now let us look at the direction of gravitational force. So in terms of direction, your gravitational force is always acting downwards. So it's always downwards towards the earth. So in terms of magnitude, this is how you calculate your magnitude, right? And in terms of direction, your gravitational force is always downward. So how do you identify that we have gravitational force? You identify using the key term mass. The moment you have mass, then it means you have gravitational force. So this is one of the forces that can act on an object. So this is one of the possible forces. So the way you identify a force is the key term mass. Okay, so force number 2 that can act on an object is what we call normal force. So what is normal force actually? So in this example, we have mentioned that we have an object of mass 5 kg, right? But then now if we go back to that object, if we further mention that this object is on a surface, okay, so it can be on top of a table, or it can be on the floor, or it can be on the roof, but as long as it's a surface, right? So this object is resting on a surface, but the object is not going through the surface, right? So the object is actually on the surface. So we do have gravitational force which is going downwards, as we have mentioned there, because there is mass, right? But also we have a reaction force on the surface there that is balancing that object not to penetrate through the surface. So this object is on the surface because of this force that we call normal force, right? So now, for example, if we had an object on a table, so this is a table, and then we have an object on a table of mass 5 kg, okay? So the fact that I said mass 5 kg, then it means we have gravitational force, right? And we have gravitational force acting downwards, okay? So now this is on a table, and we are saying that this object is resting on the table because there is a reaction force which is balancing the weight, right? Which is making that object to remain on that surface. But however, if normal force wasn't there, okay, or let's say normal force was very, very, very small, it would mean that this object would actually penetrate through the table. It will actually break the table, okay? So you'd have such situation whereby this object is breaking the table because the normal force is very, very low. But however, this object here, in this case, it's resting on the surface because of the reaction force, which we call normal force, right? So how do you know that there is normal force? So now we said the first force is gravitational force, right? And how do we identify it? We identify it using the term mass. The moment you have mass, you have gravitational force, right? So in terms of your normal force. How do you actually identify that in a specific scenario you have a normal force? Okay, you identify using the key term surface, or it can be a plane, okay, or it can be a road, it can be a table, but as long as it's a surface, then you know that you have what we call normal force. Okay, and then in terms of the magnitude, there is no specific formula. There is no, and this is very important because learners usually confuse that your normal force is always equals to the weight. So they normally they would say normal force is equals to mg, which is not always the case, right? There is no specific formula for calculating your normal force. So how do you actually calculate your normal force? You actually compute. So when we say compute, you actually calculate your normal force not using a formula, but you derive that normal force, which is what I will show in the later stage. Okay, so you derive that normal force from other forces actually, and usually those other forces, usually it's your gravitational force. You might find that your normal force is equal to your gravitational force, but that's not always the case. So that's why I say you compute or you derive your normal force. Okay, so that is how you calculate the magnitude. There's no specific formula. Okay, and then in terms of the direction, where does normal force act in terms of direction? So your normal force is always perpendicular to the surface. So it's always perpendicular to the surface, meaning that if you have a straight surface like that, then it means your normal force will act perpendicular to the surface. So there should be a 90 degrees between your surface and your normal force. So what's important here is that you have to know how to identify. The moment they say a surface, then you know that we have a force called normal force. The moment they say you have mass, now you have to know that you have a force called gravitational force. That is how you identify the forces. You identify the forces using these kind of wording. And then in terms of calculation, Fg equals to mg, and then the normal force you have to compute or you have to derive it, which is what I'll show at a later stage. All right, so we have discussed normal force to say it acts perpendicular to the surface, and for you to have this normal force, it's very, very important that you have a surface or you have a plane. Okay. All right, so the next force that can act on an object is what we call frictional force. So frictional force, it exists between your object surface and the surface that the object is in contact with, right? So it means you have your 5 kg block there, or your 5 kg object, and you have your surface there, right? As long as there is contact here, then you can have your frictional force. But however, there is a condition. So there is a condition for the surface for you to have that frictional force. Okay. And it's important to note that we said for you to have normal force, you must have a surface, right? And we can also see that for frictional force, the object must be in contact with the surface, right? So it means it's the same with frictional force. You need to have a surface, okay? You need to have a surface. This is how you identify. But now, there is a condition for that surface, and the condition says that surface, it must be a rough surface. So it's rough is the opposite of smooth, right? So it must be a rough surface. So it means that if the surface is smooth, then we have no friction. Very, very important. We have no friction. So this is how we identify these things. You have friction only if the surface is rough. But if the surface is smooth, then you have no friction, right? But if you check with the normal force, it doesn't care whether your surface is rough or your surface is smooth. But with friction, there is a condition that says if the surface is rough, then it means you have friction. So this is the key term that you have to look at, right? So there are other alternatives to the word rough. Sometimes they might use, let's say it's a road, they might use a real road. So real road, they specifying that there is friction, right? So if it's a smooth road, then that would mean that there is no friction, okay? So this is very important. So in terms of frictional force, there are two types of frictional force actually. The first one is static frictional force, and the second one is kinetic frictional force. And the difference between the two, it's quite simple if you explain in terms of movement. So the static, here the object is stationary. It means the object is not moving. So if the object is not moving, there is static frictional. There is static friction on that between the surface and the object. But however, if the object is moving, then you have kinetic friction, provided that the surface is rough. Okay. So now, how do we identify? So remember, when we talked about gravitational force, you identify it using the mass, right? If there is mass, then you know that there's gravitational force. And then in terms of calculation, Fg is equal to mg. The same thing applied to your normal force. You identify using the key term surface or a plane, okay? And then the way you calculate it is by deriving it. And then now you go to your frictional force. How do you identify your frictional force? You identify your frictional force by a rough surface, okay? So now how do you calculate your frictional force? So you calculate your frictional force, provided that maybe if the object is not moving, then we'd have static friction, okay? As we have mentioned or discussed here, up here, we said if the object is not moving, then we have static friction. And that static friction would be equals to the coefficient of static friction multiplied by the normal force. So we can see that friction actually depends on the normal force, okay? Which is very, very important. So friction is a function of, okay, to simplify it, friction depends on the normal force. That we can also see from the formula that your static friction is equal to the coefficient of coefficient of static friction multiplied by the normal force, okay? So the same logic would apply if we were to calculate the kinetic friction. That would be equal to the coefficient of kinetic friction multiplied by the normal force if the object was moving. So we can still see that your friction actually depends on the normal force, right? And in terms of relationships, you can see that the greater the normal force, the greater the friction. And the lower the normal force, the lower the friction. So it means that for you to be able to calculate friction, it's better or it's advisable that you compute or you derive your normal force first. So you should have your normal force in order to calculate your friction. So there is order, okay? So most of the time, you get your gravitational force, right, which is Fg equals to mg. And then you use that gravitational force to actually compute your normal force, okay? And then after getting your normal force, you actually use that normal force to actually calculate your friction, because your friction depends on the normal force. So that is the order that you need to identify your forces. All right, so this is how you calculate your friction, and this is how you identify your friction using a rough surface. So now let us talk about the direction of friction. So friction, in terms of direction, it opposes the motion, or it opposes the direction of motion. So for example, if the object is moving to the right, okay, if the object is moving to the right, then it means that friction would move to the left. That would be your friction. For example, if your object is moving to the right, to the left, then it means your friction would move or would point to the right. So it always opposes the motion. So for you to get the direction, actually, you need to identify where the object is going. So for you to get the direction, you need to identify where the object is going. Because now sometimes you get confusion when learners say friction opposes the applied force, which is the next force that we'll talk about. So it's not that it opposes the applied force, it actually opposes the direction of motion. Okay, so you need to identify the direction of motion first. Okay, so now let us go to the next force. And the next two forces, actually, I usually combine them to be applied forces, okay? But the first force is an applied force, which is a force that you're usually given. It can be applied by an external object, okay? So let's say, for example, there is a person who's pushing a box of mass 5 kg. So if this person is pushing, this person is physically applying a force. So that's an applied force. So it's applied, it can be applied by an external object, okay? So in terms of identification, you are told that there is an applied force of maybe 50 newtons, for example. There's no really a term that or a key term that you can use to identify your applied force, right? Because a key term in terms of friction is the word rough, okay? And then a key term in terms of normal force is the word surface. You just need to have a surface. And then a key term in terms of your gravitational force, you just need to have your mass. But when it comes to the applied force, they actually tell you that there is an applied force. So we can say that the key term is the applied, actually. So if they say an object, a person applies a force of 50 newton, then you know that that is your applied force. And usually they will tell you the direction where that applied force is applied. So now the next force is what we call tension. So this tension force, so firstly, I would like to explain when do we have a tension force. So when do we identify a tension force? So in terms of identification, we use the key term string. So as long as you have a string, there is tension acting on that string, okay? Another alternative, they might use a rope, okay? So if you have a string, then it means you have tension acting on that string. If you have a rope, it means you have tension acting on that rope. So that is how you identify your tension. So tension actually is very, very similar to your applied force. And then in terms of direction, where your tension is going, you actually evaluate your diagram. Let's say, for example, you are given that is 5 kg and that is a surface. So the fact that we said 5 kg, then we know that there is gravitational force, right? And then it's on a surface, then you know that you have normal force. And if it's on a rough surface, then you know that you have friction, okay? And then we say there is a rope which is attached to that 5 kg object, and then someone is pulling on that rope. The fact that this person is pulling on that rope, right? The person is applying the force on the rope, and then the rope is applying a force on the object. So this, instead of us calling this an applied force now, we will call it tension, okay? Because it's on a rope. So that's how we identify. And in terms of calculation, there's no specific formula for calculating the tension in this case. So that is how you actually identify the forces that are acting on an object, okay? So now we know that there are 5 possible forces that can act on an object, which is your gravitational force, your normal force, your frictional force, your applied force, and your tension, okay? And then how do you identify those forces? You identify those forces using key terms, okay? So how do you identify your gravitational force? You identify your gravitational force using the word mass, okay? Or the key term mass. Then you know that you have gravitational force. And then how do you identify your normal force? Surface is your key term. How do you identify your frictional force? Rough surface is your key term. And then how do you identify your applied force? They usually mention that, you know what, there is a force which is applied on that object in a specific direction. And then in terms of tension, how do you identify your tension? You identify your tension using the key term string or a rope, okay? So now, how do you visualize these forces? How do you represent these forces in a diagram? And the main reason for you to represent these forces in a diagram is for you it actually simplifies the problem, okay? So you see from a visual perspective how many forces are acting on an object. So we visualize using what we call a free body diagram or a force diagram. Okay, so a free body diagram is a diagram that is represented by a dot, okay? And then all the forces that are acting on this object, they are drawn from this point, okay? For example, in this object, we can see that we have mass 5 kg, meaning that we have gravitational force. And we said gravitational force is always acting downwards. So we know that there is a force of gravity which is acting downwards, okay? And then we can see that there is a surface in this case. And the fact that there is a surface, we have normal force, okay? And also, normal force is always perpendicular to the surface. So it means in this case, it would go like that. So there should be a 90 degrees between the surface and the normal force. So on your free body diagram, this is how you draw your normal force, which is your normal force N, okay? So now, if the object was moving on a rough surface, if there is a rough surface, okay, it means that we have friction. And if the object was moving to, let's say, to the left, if the object was moving towards the left, then it means your friction would move towards the right. So all of the forces that are present, you draw them on a free body diagram. Now, if we look at this diagram, we can visually see that there are three forces acting on an object, on that object, which is gravitational force because there is mass, which is normal force because there is a surface, which is friction because there is a rough surface. Okay, and then let's say, for example, an applied force of 50 newtons was applied there. So it means on that diagram now you always, you'll have your applied force acting to the left, not to the right, sorry, acting to the left. So now you can see that there are four forces acting on that object. So this is how you visualize your forces. So we, from the outcomes now, we know that we know the possible forces that can act on an object, and we also know how to identify these forces using key terms. And now we can get a feel of how to visualize these forces. So in the next lessons, I'll be doing examples of a scenario whereby I'll identify all the forces that are acting on an object. And then after identifying all those forces, I will visually represent them using a free body diagram.